I wanted to make a video showing integration by parts. And so the way to find the formula for integration by parts is to start with the product rule, which can be written as a prime b plus b prime a, or you could have a b prime plus b a prime. It really doesn't matter. So to start here, what you would do is, okay, this is to find the derivative with respect to whatever variable you have of a times b. So if we take the integral of both sides of this equation, we're going to get that the integral a prime b plus b prime a equals ab. And so here, if we subtract off, this can be split into two integrals. So if we subtract away either one of these integrals, we're going to get the integration by parts formula. So we'll get that a prime b equals a times b minus the integral of b prime a. And if your original integral here has bounds of n to m, then your secondary integral here will have the bounds n to m. So, to show an example here, let's take the integral of x times e to the x dx. And we're going to keep this indefinite, so we're not going to have any bounds. So by our formula, we want to call one of these things a prime and one of them b. So here, let's call x b, because when we take the derivative of that, we're just going to get 1, and that's going to show up in our final integral, which will simplify it. So that leaves a prime is equal to e to the x, and from our knowledge of e to the x, that means that a must also equal e to the x. Now what you want to do is rewrite your integral according to this formula. So we're going to say that the integral of x e to the x is equal to, well, that's x e to the x minus the integral of, and now we're going to have b prime times a, so that's e to the x times 1. Okay, and this is still dx. So if we start to evaluate this, we're going to carry down our x e to the x. We're going to have a minus, and the integral here is just going to be an e to the x, so we're going to get e to the x, and since this is indefinite, we can add our plus c, and that's how you find the integral of that using integration by parts.